Alright, so for finding the vertex of a quadratic function, if it's already written in vertex form, it's really easy. Remember, vertex form is a x minus h squared plus k, and our vertex is hk. It's also important to remember that in vertex form, h is negative, so when you take h out, it's technically the opposite sign. So looking at a, we have negative 8, x minus 8, so it's actually a positive 8, and then a 3. For b, we need to put it in vertex form. So a equals a. So since our a and b is 2, we're going to have a 2. X, whatever h is, squared. So then to get h, we do negative b over 2a. b is negative 14, so we change the sign and make it positive, over 2, and our a is 2. 2 times 2 is 4, so we have 14 divided by 4, and when you do that, you get 3.5. So it's going to be minus 3.5 for h. You can also leave it in fraction form, which would be 7/2, either way. And then to get k, we take our h value and put it back into our function where x is. So we get 2, 3.5 squared minus 14 times 3.5 plus 1. When we put this in the calculator, we get negative 23.5. So this is the vertex form of our function, and our vertex is hk, so it's going to be a positive 3.5 and comma negative 23.5 for our vertex. So a is 8 and 3, b is 3.5, negative 23.5. For c, we do the same thing. A equals a, which is 3, so 3 parentheses x something squared. To get h, it's negative b over 2a. b is there is no b. Remember, it's a x squared plus bx plus c. Since there is no middle term, that would be the one that's x to the first power. b would be 0. So this is our actual vertex form. So then when we do it, it's going to be 0, 18. So you know to stop when there is no b value. For determining the axis of symmetry, all it is your h value. So it's going to be x equals negative 4. For the next one, we can do h equals negative b over 2a again. Since b is negative 10, we're going to make it a positive 10 over 2 times negative 6. When we do this, 2 times negative 6 is negative 12. You can reduce the fraction and get negative 5/6, or put it in decimal form, which would be negative 0.83. So it's going to be x equals negative 5/6 or negative 0.83. Remember, your axis of symmetry is a line, so that's why we got to have the x equals a number. For number 3, it's putting it into vertex form, so it's doing what we did up in number 1 with b. So you can just do what we did. It's going to be a equals a again, which is 2. h is negative b over 2a. b is 12, so it's negative 12 over 2 times 2. 2 times 2 is 4. Negative 12 divided by 4 gives you negative 3 for h. X, instead of making it a negative 3, we'll make it a positive 3 squared. And then to get our k value, we're going to take negative 3 and sub it in for x. So we get 2 times negative 3 squared plus 12 times negative 3 minus 5 gives us negative 23 for k. And you do the same thing for b. Writing it in standard form, all you do is your PEMDAS or order of operations. So for number 4b, we're going to expand x minus 3 squared. Remember, if you have an addition or subtraction sign in between two terms, you cannot distribute your exponent. So it's going to be x minus 3 times x minus 3 minus 7. And remember, your order of operations starts with parentheses and exponents. So we're going to actually multiply x minus 3 and x minus 3 first. When you do that, you get x squared negative 6x plus 9 minus 7. You can do the box method if you can't do that in your head. You just multiply it like that and combine like terms, which would be those two. And you would get the same thing. Then we do our parentheses next. We got to do our multiplying. We're going to distribute our 5 and we get 5x squared minus 30x plus 45 minus 7. And then again, we just combine like terms, which would be 45 and 7. And so you get 5x squared minus 30x plus 38. And that would be writing that vertex form into standard form. Remember, standard form is ax squared plus bx plus c. For number 5, it says sketch the graph of each function and then identify the information listed below. So when we sketch it, remember our parent function is x squared. So what's happening is it's a stretch. It's going left 3, remember always is the opposite, and then down 2. So our vertex is at negative 3, negative 2. So we're going to go left 3 and down 2. And you can use your transformation table. We have x, y. Remember it's negative 2, negative 1, 0, 1, and 2. And we get 4, 1, 0, 1, 4. So what's happening to our x value? X is being subtracted by 3. What's happening to our y value? We're multiplying it by 2. And we're also moving it down 2. Remember, if you take out what's happening to x and change this to a y, you get 2y minus 2, and that should match what's over there. So negative 2 minus 3 gives us negative 5. Negative 1 minus 3 is negative 4. And this should go down in descending order. Then we do our y. 4 times 2 is 8. Minus 2 gives us 6. What happens up here happens down here. 1 times 2 is 2. Minus 2 we get 0 for both 1's. And then 0 times 2 is 0. Minus 2 gives us negative 2. And again, this should be our vertex, which we've already graphed down here. So we get negative 4, 0, and negative 2, 0. And we have negative 5, 6. 1, 2, 3, 4, 5, 6. And that also happens with our negative 1 is up 6. So then we plot our points. We connect everything. So finding our vertex, we already stated that it's negative 3, negative 2. You can either look at the graph or look at the table. Our axis of symmetry is what our x value is of our vertex. So it's x equals negative 3. Our intervals of increase and decreasing, let's do our domain and range first. Domain for all quadratics, all polynomials is all real numbers or negative infinity to infinity. Our range, we were bottoms up. We start at y equals negative 2. So it's from negative 2 to infinity. And remember, since it's range, if we reach that value, it gets a bracket. Since we're touching -2, it gets a bracket. We can never reach infinity, which is why that gets a parentheses. So intervals of increase, it's increasing in this direction. So think of an ant, they're now walking uphill, very steep like. So the ant's going uphill, or you're walking upstairs, however you want to think about it, from what x value? Well, we're doing it from our axis of symmetry, which is -3, and it goes all the way to positive infinity. Our intervals of decreasing is going to be the exact opposite. It's decreasing this way, so it's -infinity to -3. And then what's our end behavior? It's as x goes towards -infinity, where is the function going? And as x is going towards positive infinity, where is the function going? And since it's a quadratic function, and our arms of our function are going the same direction, are they going up or down? Since they're going up, they're going towards positive infinity in both directions. So that's how you would graph your functions and then find the information from them. To match each characteristic with the proper graph, we can kind of break them all apart. We have the axis of symmetry is -1. So if we draw our line, our axis of symmetry here is x equals 4. Our axis of symmetry here is x equals -1. Axis of symmetry here is x equals -4. Our axis of symmetry here is x equals 0. So the only function where our axis of symmetry is x equals -1 would be this one. So this one is C. Has an interval of increasing from -4 to infinity. So the only one, and remember our intervals of increasing and decreasing rely on where our vertex is for quadratic functions. So the only one where our vertex is at -4 is right here, and it's increasing from -4 to infinity. So this one is A. B says has an interval of decreasing from -infinity to 4. So the one that's decreasing, remember it's got to go around our vertex. Our vertex here is 4, -2. So it's decreasing from -infinity down to where x is 4. So this one is B. And then our last one, just to double check, it says a vertex of 0, -4. Well, 0, -4 is right here, so this is D. Then it says describe the transformations for each function. So let's look at A. It's reflected because of the negative. It's going right 4. Remember, you do the opposite of what it looks like. And then down 3. Remember, it's A, x minus h squared, plus k. This is your vertical translation. This is horizontal. If A is less than 1, it's a shrink. And if A is greater than 1, it's a stretch. And if A is a negative number, it's reflected. Then it says write the equation in vertex form for the graph quadratic function below. And we need to find our vertex. That'll help us out a lot. So our vertex here is -3, 1. So it's going to be x, instead of -3, 1 to be a +3 squared plus 1. And since it's opening up, it's going to be positive. In B, our vertex is 4, 1. So when we put that in our function, we have x minus 4, remember change the sign, plus 1. And since it's opening down, we need a negative sign out in front. You're not going to have to worry too much about the A value, what it is. At number 9, Paul jumps off a 6-foot diving board at his pool and performs a cannonball dive. His height as he dives follows a quadratic function. H of t is the following as a function of time. Determine the vertex for this function and then describe the vertex represents in context of Paul's dive. So you're going to need to put it in vertex form, or at least find H and K. You do know that A is 4, so to find H, it's negative b over 2a, so it's going to be 14 over 2 times 4, which is 8. And when you get the decimal for that, it's 14 divided by 8, which is 1.75. So it's x minus 1.75 squared. Take that value, put it where t is to get your k value. So it's 4 times 1.75 squared minus 14 times 1.75, and then plus 6, and we get negative 6.25. So the vertex would be 1.75 comma negative 6.25. So for 9 for part A, you're going to need to put it in vertex form, at least find H and K. And then for B, you're going to set the function equal to 0 and solve for T. For 10, just explain the equation. Why does it have solutions x equals 7, x equals negative 11 versus x equals negative 7 and x equals 11? Remember, you need to set them equal to 0. So set them equal to 0 before you explain why. Solving the equation, you're just factoring and solving by factoring. In A, you can just simply factor what times what gives me x squared. It's x and x. What are the factors of 10? Since 10 is negative, we're going to subtract those factors. What factors of 10 subtract to give us 3? It's 5 and 2. And which one has to be negative to make our 3 negative? And it's our largest factor, which is 5. And we just set each one equal to 0 and solve for x. So we're going to add 5 to both sides. X equals 5. Subtract 2 from both sides, and x equals negative 2. So our solutions are negative 2 and 5 for A. If you can get a greatest common factor out, go ahead and do that. Let's look at F. You need to get it all on one side first, so we get 5x squared minus 30x equals 0. Get your greatest common factor out, which is 5 and an x. So x minus 6 equals 0. And we're going to set each factor equal to 0. So 5x equals 0. Divide by 5. X is 0. And then x minus 6 equals 0. Add 6 to both sides. And we get x is 6 as well. So those are our solutions for that one. Let's look at one where A is not 1 and where you cannot get a GCF out, which would be B. There is no greatest common factor. So we're going to draw our box, first in the first, last in the last. And then to get rid of that A value, we're going to multiply it to our last term, so we get negative 24. What factors of negative 24 subtract to give us 5? So we think about what could it be, and our factors are 8 and 3. So which factor has to be positive to keep my 5x positive? And it's our 8. So 3 needs to be negative. So then we get our greatest common factor out of each column and row. So in the first column, our greatest common factor is x. In our second column, our greatest common factor is 4. In our first row, our greatest common factors are 2 and x. And in our last row, our greatest common factor is negative 3. Remember, follow the leader. So x plus 4 equals 0. Subtract 4. X is negative 4. 2x minus 3 equals 0. Add 3. 2x equals 3. Divide by 2. X is 3 halves. So our solutions are negative 4 and 3 halves. So that's how you do those for whichever form you get. Solving inequalities, you do what we did above. You're first going to solve it. So let's look at A. It's x squared. We need to get it all equal to 0. Remember, change that inequality sign to equals. So it's x squared minus 5x minus 36 equals 0. Factor it out. What times what gives me x squared? And it's x and x. What are my factors of 36 that subtract to give me 5? And it's 9 and 4. So we're going to have a 9 and a 4. Which one has to be negative to keep my 5x negative? The 9. So our solutions are going to be x equals negative 4 and positive 9. Okay, that's solving an equation. We're not solving an equation, we're solving an inequality. So we need to do our number line. We have a negative 4, we have a 9. We've got to pick a number less than 4, a number in between 4 and 9, and a number greater than 9. Put them into the function we were given and simplify and see if that statement's true or false. So let's look at negative 5. It's less than negative 4. Negative 5 squared is 25. 5 times negative 5 is negative 25. And then plus 36 gives me 11. So is 25 bigger than 11? Yes, so we're going to put a check mark above that. Then we pick a number in between negative 4 and 9. Let's do 0. So 0 is greater than 5 times 0 is 0 plus 36 leaves us 36. Is this a true statement? No. So we put an X above that. Then we do something bigger than 9. Let's do 10. 10 squared is 100. 5 times 10 is 50. Plus 36 gives us 86. Is this a true statement? Yes. It gets a check. Since it's a greater than sign and it does not have a less than sign, we're going to have open circles and we're going to shade towards where we have our check marks. So we're going to write down negative 4. We know that x is less than negative 4. Or we have a 9 and we know that x is greater than 9. So that's how you're going to do your inequalities. You've got to test points. For 13, super easy. You do a line at where where our function is 5. So we're doing a dotted line since there's no line underneath the inequality. And it says f of x is greater than. So I'm going to shade greater than that. Then we need to find out what these x values are. So we're going to go down to our x-axis and we have negative 7. X we know is less than negative 7. And we also know that x is greater than 5. If we look at B, we have negative 3, and it's going to be a solid line now because we have a line underneath the inequality, and it says f of x is greater than. So I'm going to shade above that line. Again, find out where your x values are. We have 1 and 5, and x is in between them. We want to shade that way. So we want bigger values than 1, and we shade this way. We want less values than 5. Alright, to compare and contrast the long run rates of change for linear, quadratic, and exponential functions. We know that exponential functions are always going to end up beating linear and quadratic. Determine which function has a greater rate of change on the interval from x negative 3 to x equals 1. We need to find our point where x is negative 3 and where x is 1. So negative 3, for our exponential, we have negative 3, negative 3. You can also take negative 3 and put it where x is into the function, and where x is 1, which is right about here, and it's not exactly on that mark, so we probably want to plug that in. And we get negative 1, comma, negative 0.85, and you get that from putting it in the calculator. We're now going to do our f of x function, our quadratic function. It's negative 3 and negative 3, negative 5, and it's 1 at 1, 3. So average rate of change formula is y2 minus y1 over x2 minus x1. So let's do our quadratic function first. We have y2, which is 3, minus our y2, which is negative 5. So minus a negative makes it positive. Then we're going to divide it by x2 minus x1. So 1 minus a negative makes it a positive 3. And we get 3 plus 5 is 8. 1 plus 3 is 4. Our average rate of change for a quadratic function is 2. Exponential, do the same thing. We have y2 minus y1, so negative 0.85 minus a negative 3 makes it a positive 3. And then 1 minus a negative 3 makes it a positive 3. So negative 0.85 plus 3 is 2.15 divided by 4, and you get 0.538. So which one has the highest average rate of change? It's 2. So which one from the interval negative 3 to 1 has a higher average rate of change? It would be your quadratic function, which is f of x. Then it says describe how to use the method of finite differences to determine whether or not a sequence follows a linear or quadratic pattern. If it's linear, it has a difference of 1. Quadratic, common difference of 2. So what that means is we've got, these are our x values, these are our y values. We're going to subtract. We have negative 94 and 69. It's getting, so we're going to have a 25, negative 25. We're going a little backwards. 69 and 48, this is negative 21. 48 and 31 is 17. 31 and 18 is 13. 18 and 9 is negative 9. 9 and 4 is negative 5. So then we need to find our second difference. Because obviously if all of these were the same, it would be linear. And it's not. So now we need to find our second difference. 25 and 21 is 4. 21 and 17 is 4. 13 and 17 is 4. 9 and 13 is 4. 5 and 9 is 4. So, and they're all going to be negative 4. So, because we have a common second difference of 4, it's going to be quadratic. For our linear, you do the same thing, but it should stop at the first difference. So we do 451 and 478, and the difference between those is 27, increasing, so it's going to be positive. 505 and 478 gives us 27. 532 and 505 is 27. 559 and 532 is 27. 586 and 559 is 27. And 613 and 586 is 27. Since they all have the same common difference in the first difference, then it's going to be linear. So that explains why it's linear.